In this video, we're going to find the formula for a parabola when given the focus and the directrix. If you remember before, we had to find the formula, but we were given the vertex and the directrix, and we just plugged it all in this handy-dandy formula. Well, it's still pretty much the same thing, except for instead of the vertex, they give us the focus. So from the focus, we can figure out what the vertex is, plug it in, that handy-dandy little formula, and then find the equation of that parabola, okay? So remember, the vertex is just halfway between this focus and the directrix. If I could just, because remember they're equidistant, so it's the same distance from here to here as it is from here to here. So if I could just figure out the distance from here all the way down to here and divide it by 2, guess what? I'll find my vertex. Okay, so basically I'm just going to take the absolute value of this y-coordinate up here, 6, minus 2, minus this y-coordinate down here, okay? So my new y-coordinate is going to be the absolute value of 6 minus 2, and then I'm going to divide that by 2. I'm divide it by 2. Well, 6 minus 2 is 4, so y equals 4 divided by 2. So my new y-coordinate is going to be 2, which means it's basically just going to go up to 1, 2. Now my x value doesn't change in this scenario because look, my vertex is just going to go up from here, but it's never going to go left or right in this case. So my x coordinate is going to stay the same. So my vertex, I found out, is 4, because that doesn't change, 2. So over 4 up 2. And that is my vertex. Now I know my vertex is 4, 2, and I'm just going to rewrite my directrix down here so I have it y equals 6. And now that I have my vertex and my directrix, I can go back to my formula and say, okay, my directrix is y equals 6, so that means I go opposite day, and I go and I put the x's first, because that means my parabola goes up or down. And you can tell just by the drawing of this parabola, it goes down, so I would use this one and not this one, because it goes down. So I'll just rewrite the formula over here. X minus h squared equals 4 times p times y minus k, and remember it's not squared. All right, now I got to find p, okay? P, if you remember, is the distance between the vertices and the directrix. Well, we kind of already found that because we did the whole thing and then we divided it by 2. Well, the whole thing, the distance was, well, actually, no, let's scratch that. The distance between, let's just say, the vertex and the focus. Well, remember, I said you can take this and these two things, okay, and subtract them from one another, and you will find that distance. Okay, I had to pause just to make sure that I was correct. I was correct. So remember, just a second ago when we found that this whole distance between them, and then we divided by 2 is 2, I could just multiply that 2, and by 2, I could just double it, and I would find my p. But let's just go back to what we were doing before, which is to find p. I say, well, if I know this is y, then I'm going to use this y coordinate, and I say this minus this, and so I say 2 minus 6, and I get negative 4. Okay, so I take this y coordinate of the vertex and I subtract the directrix. 2 minus 6 equals negative 4. Now I can just plug that in to p. I can plug in my h and my k because I found my vertex, and now I'm going to easily find the equation of my parabola. So I get x minus 4 squared equals 4 times negative 4 times y minus 2. And all I have to do is multiply that out, and voila, that's my answer. X minus 4 squared equals negative 16 times y minus 2. Now, eventually, you may have to learn how to actually solve for x, and that's a whole nother ball of wax, and it's really not too complicated, but this is the way Alex is going to want you to initially put in your answers. So that's how you find it, using the focus and the directrix. I'll do another example when we have a parabola going left or right.